Good afternoon, everybody. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Hadiyar. In the previous session, we were discussing about Fourier series expansion of certain functions with period 2 pi and arbitrary period. I hope everybody are clear with the concept of finding Fourier series expansion in the two intervals, that is one is 0, 2 pi where the period is 2 pi. In the case of period 2 pi and arbitrary period. Anybody has any doubt? I hope you people are thorough with these two topics. Fourier series of period 2 pi and Fourier series of arbitrary period. Okay, then today onwards we'll discuss about Fourier half-range Fourier series. We'll discuss about half-range Fourier series. This is also similar concept. So we will be having certain changes that we will know while we discuss the questions. So here it will be mentioned you will have two types, half-range Fourier sine series and cos half-range Fourier series. So there are two types. First one is Is it okay, everyone? Hope you all can see the screen.
Yes, ma'am.
Okay, so now listen carefully. I'll repeat once again. Suppose if you have an interval of length 2L, we have seen that in general a periodic function of x will have Fourier expansion containing cosine terms as well as sine terms, because the standard expansion, look at this, we have a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by L. This is in the case of arbitrary period. Suppose if you have arbitrary period plus summation n equal to 1 to infinity bn sine n pi x by L. This is a general form in the case of arbitrary period. It has both sine and cosine terms, isn't it? Now, many times it becomes necessary to have the expansion containing only sine terms and only cosine terms. That is in the case of odd and even functions. We know that when the function is even, bn will be 0, so we will have the expansion in terms of cosine term only. Suppose when the function is odd, when function is odd, a0 and an both will be 0, that time we will have the Fourier series expansion with respect to sine terms only. So now here, in order to achieve this, suppose if you want only a sine half range sine series, half range cosine series. So in order to achieve this, the function must be defined in the interval of the form 0, L. See, this is defined in the interval 0, 2L, entire period. Suppose if it is taken half of that, this is regarded as the half of the interval, half of the interval. So we can extend the definition to other half in such a manner that function becomes even or odd. So only when the function becomes even or odd, we can have a Fourier series with respect to cosine only or with respect to sine only. So that is what we require here in our half range Fourier series. We may need to require Fourier series expansion of certain functions with respect to sine and cosine terms only, either sine terms or cosine term. That's why we reduce the entire interval, that is, suppose if we have length 2L, period 2L, we reduce it to half of it. So it will be 0, L. Next, formulas, everything will be same as that of the previous one. So we'll discuss few questions. Obtain half range Fourier series of, we'll discuss the first question. Obtain the sine half range Fourier series of f of x is equal to x square in 0 less than x less than pi. We need to find the Fourier series half range, sine half range Fourier series of f of x equal to x square in the interval 0 less than x less than pi. So first thing what we need to do is, here they specifically said sine half range Fourier series. What do you mean by sine half range Fourier series? You need to write the general expansion. You should have the Fourier series expansion with respect to sine term only. So in order to have the sine term, we should have the interval, Fourier series expansion like this. F of x equal to summation n equal to 1 to infinity bn sine nx. Only in this case. Otherwise, we cannot get a sine half range series. Only when a0 and an are 0, we will get the expansion in terms of bn only. We get the expansion in terms of bn only. Then only we can say that we will have a Fourier series, sine half range Fourier series expansion. So as it is specifically mentioned, we need to use the sine half range. We need to get the sine half range Fourier series. Sine half range Fourier series is obtained by f of x is equal to summation n equal to 1 to infinity bn sine nx. Well, what is the formula of bn? Bn is nothing but 2 by pi integral 0 to pi f of x sine nx dx. You need to be careful here, it is 0 pi, interval is 0 pi. So you need to put the formula according to that. Next, here let us find out the value of bn. Bn will be what? 2 by pi integral 0 to pi f of x is given to be x square sine nx dx. That is equal to 2 by pi. Now you need to apply Bernoulli's rule in order to find the product integral of product of two functions. Take x square as the first term and sine nx as the second term. So you need to integrate applying Bernoulli's rule. First term, keep it as it is, x square, integrate sine nx. Integration of sine nx is what? What is integration of sine nx? Minus cos nx divided by n. Then negative sign, differentiate x square. It is 2x. Integrate this one. What is integration of cos? It is sine. Negative sign is already there, so it will be minus sine nx by n, and previously 1 n, so it will become n square. Then plus differentiation of 2x. What is the differentiation of 2x? It is 2. Integrate this once again. Integration of sine will be what? It is minus cos minus, or with this minus it will become plus cos nx by n. With this n square it will become n cube, and the limit vary from 0 to pi. We can check that for n equal to 0 and pi, sin nx will be 0, therefore the middle term will be 0. Next we need to put the limits for the remaining terms. So we have 2 by pi. Here there is minus 1 by n. So we can take that outside. Minus 1 by n into what is remaining? X square into cos nx. X square into cos nx, and the limits will be vary from 0 to pi. So this term will be 0. Last term will be there, that is 2 by n cube into, put the limits, cos nx, limit vary from 0 to pi. Let us put the limits. So what do we get when we put the limits? 2 by pi into minus 1 by n. When we put the limit, that is pi, it will be pi square into cos n pi. Cos 1 pi can be written, n pi can be written as minus 1 power n. When you put the lower limit, it will be 0. Plus 2 by n cube into upper limit is cos n pi minus cos 0. So this is what we get it. Now let us further simplify this. What do we get? 2 by pi into, you can take few terms over here. What happens? This is minus 1 power n into minus 1 power 1. So it will be minus 1 power n plus 1 into pi square by n. Then here it will be 2 by n cube. Correct? Cos n pi will be what? Minus 1 power n. Cos 0 value is 1. So this is the value of Bn. What is the Fourier series expansion? That is summation n equal to 1 to infinity Bn sin nx. So when we substitute the value of Bn, what do we get? Summation n equal to 1 to infinity. What is the value of Bn? We have calculated, that is 2 by pi minus 1 power n plus 1 into pi square by n plus 2 by n cube into minus 1 power n minus 1. This has asked in December 17 question paper. So we have expressed the Fourier series f of x equal to x square. We have found half range sine series. Half range sine series. Why is it especially used? Suppose if you want the Fourier series expansion with respect to sine term only, or with respect to cosine term only, then what do? Given an interval or a period, we reduce it to half of it. Then we can apply the certain formulae in order to find the Fourier series expansion. Anybody has any doubt? Anybody wants to ask anything? Anybody has any doubt? So let us discuss few more questions. If you have doubt, you can ask later. So we'll discuss one more question. This has been asked in June 2018 question paper. They have asked, find the sine half range series for the function f of x is equal to Lx minus x square in 0 less than x less than L. They have asked us to find the sine half range series. We need to find the sine half range series of f of x is equal to Lx minus x square, where x lies between 0 and L. Okay, now first they have asked sine half range series. So sine half range series is obtained by, write the general formula. Sine half range series means it contains term with respect to sine only, and this is an arbitrary period. See, L is given. So what will be the formula? It will be summation n equal to 1 to infinity Bn sine n pi x divided by L. Remember that if it is not arbitrary period, that means suppose if it is 0 comma pi, then it will be only sine nx. But as you have arbitrary period, it will be sine n pi x divided by L. I hope this is clear to everybody. The formula, the difference between the previous question and this question. Previous question we had f of x is equal to x square in the interval 0 comma pi, where the formula will be summation n equal to 1 to infinity bn sine nx. Entire thing depends on the interval. Here the interval is 0 comma L, arbitrary period. That's why we have to write the formula as sine n pi x by L. Series n equal to 1 to infinity bn sine n pi x by L. Those who have attended my previous session, they will understand for sure. Rest you practice. Next, we will do it. We can write the formula of Bn. What is the formula of Bn? Same formula what we have used when we solved the Fourier series expansion for arbitrary period. What is the formula of Bn? Can anybody tell me? Anybody? What formula did we use for Bn? Chaitranjali, what is the formula? Mega?
2 by L 0 to L.
Afterwards? What happened afterwards? F of x? No, correct. Sin n pi x by L dx. This is the formula which we have used in the case of arbitrary period. So even though here it is given to be 0 comma L, we have to use the same formula because we are reducing the entire interval of period 2L to L, half of it. So it will be 2 by L, 0 to L. All formulas are same, but you need to know how when to do the modification. So Bn will be 2 by L, 0 to L, f of x sin n pi L dx. So that is equal to, now what do we have? 2 by L integral 0 to L, f of x is Lx minus x square into sin n pi x divided by L into dx. Next, what we do is we take Lx minus x square as the first function, sin n pi x by L as the second one, and let's apply the Bernoulli's rule. 2 by L into first term will be kept as it is. So Lx minus x square into second term, integration of sin is minus cos n pi x divided by L whole divided by the constant term, that is n pi x by L, n pi by L. Then negative, differentiate Lx. Differentiation of Lx is L minus differentiation of x square is 2x into integrate this. Integration of cos is sine, negative sign is already there, so it is sine n pi x by L divided by n pi by L. Previously we have n pi by L, so it will become n pi by L whole square. Then plus, differentiate this one. Differentiation of L is 0, differentiation of minus 2x is minus 2. So it's minus 2 into integration of sine. Integration of sine is minus cos, minus of minus will be plus cos n pi x by L whole divided by n pi by L, and here we have n pi by L whole square. So it is n pi by L whole cube, and the limit vary from 0 to L. Is it okay? Anybody has any doubt here in applying Bernoulli's rule? Anybody has any doubt in this rule, Bernoulli's rule?
No, ma'am. No, ma'am.
Okay, now apply the limits. What happens when you apply the limits? See, just you can check this for the middle term. If you put L here, L get cancelled, sin n pi. Sin n pi is 0. Similarly, when you put the lower limit 0, sin 0 will be 0. So the middle term will be 0. Let's apply the limit for first and the third term. So it's 2 by L. Here n pi by L is there. It's 1 divided by n pi by L. So when you take it to the numerator, it will be L by n pi. Then put the limit for this term. So when you put upper limit, what is the upper limit? L. So when you put L, x as L into L square minus L square. So when you put the upper limit, it will be 0. Then minus, I'll take with this negative sign also outside. Negative sign, let us keep it outside. Now put the lower limit, that is x as 0. What happens when you put x as 0? Even that time it will be 0 because 0 minus 0 it's 0. So when you put the both upper and lower limit, this term also will be 0. So you need not write that. This term also going to be 0. Then this will be 0. Come to the third term. It's n pi by L whole cube. Minus 2 is already there. N pi by L whole cube. 1 divided by n pi by L whole cube. So it will be L cube divided by n cube pi cube. Then we have the limit, upper limit. So if you replace x by L get cancels, cos n pi remains. Similarly, when you put x as 0, it will be cos 0. This is what we get it. So that is equal to, you can simplify few terms. So L get cancels over here. 1 L get cancels. Cos n pi is minus 1 power n. Cos 0 is 1. So what do we have over here is minus 4L square divided by n cube pi cube into minus 1 power n minus 1. Is it? Or you can take the negative sign inside. Bn will be, minus sign will take it inside. So it will be 4L square divided by n cube pi cube. So if I multiply by minus 1, it will be 1 minus 1 power n. This is the value of Bn. So what is our sine half range Fourier series? Sine half range Fourier series will be summation n equal to 1 to infinity Bn sin n pi x by L, where what is the value of Bn? Summation n into 1 minus 1 power n sin n pi x by L. So this is asked in June 18 question paper. Very easy concept this is. So I'll need to practice more questions so that it will be easy for you all to do it during the exam time. Anybody wants to ask anything? Anybody has any doubt?
No, ma'am.
So those who have attended my previous classes, they'll find it easier because these are all class interrelated. I have been starting with Fourier series because that is there for your internal, which will be on 28th. Your internal begins, final third internal. So attend my classes. So we'll discuss one more question. Expand the function. We need to find. Now let us question. I have solved two questions on half range sine series. So let me discuss question on half range cosine series now. So find half range cosine series. Half range cosine series. Cosine series for f of x is equal to x minus 1 whole square in the interval 0, 1. We need to find the half range cosine series for the function f of x equal to x minus 1 whole square in the interval 0, 1. So how to solve this? They have asked us the Fourier's cosine series, half range cosine series. How a half range cosine series will be? Bn term only will be 0. We will have the other two terms, a0 by 2 plus summation n equal to 1 to infinity an. See, this is arbitrary period. So it will be cos n pi x by L. It will be n pi x divided by L. So let us find the two constants a0 and an respectively. What is a0? It is 2 by L integral 0 to L f of x dx. This is the formula. So it's 2 divided by L. What is the value of L? How to find the value of L now? What is the value of L? Tell me. Can anybody tell me what is the value of L? How much? Repeat once again. What is the value of L? Are you all there
1,
in the
ma'am.
class? Okay. Anybody else? What is the value of L?
1, ma'am. 1, ma'am.
Okay. Okay. I do not know how many of you have guessed it or how many of you understand the concept why it is 1. See, when you have the full range, that time it is 0, 2L, correct? And in that case, suppose if you have the interval 0, 1, the period is 1, you need to compare with 2L. In that case, L will be half. But here you have half range. Our interval is 0, L. Correct? Our interval is 0, L. And find the length, and you need to compare this with L only. What is the interval? 0, 1. Length of the interval is 1, 0, which is 1. And you need to equate this with L only. That's why L value is 1. I exactly do not know how many of you have guessed it, but this is the reason why L equal to 1. So you need to understand the difference between two things clearly. When it is full range, find the period, equate it with the 2L, L will be half. But here we are discussing half range. Half range means the interval will be of length L only. So this interval is 0, 1, length of the interval is 1. You need to compare with L, not 2L. That's why the value of L is 1. So you need to be careful, because when you study all things at a time, there is some confusion. So understand why L is equal to 1. Just do not guess it. So its value is 1, integral 0 to 1, f of x is what? X minus 1 whole square into dx. So it will be 2 into integration of x minus 1 whole square will be x minus 1 whole cube divided by 3. Limits vary from 0 to 1. So it is 2 by 3. Let us put the limit. So when you put x as 1, 1 minus 1 whole cube 0, lower limit will be 0. So if you put x as 0, minus 1 whole cube will be minus 1 itself. So minus of minus, it will be plus. That's why a0 value is 2 by 3. If a0 is 2 by 3, a0 by 2 will be 1 divided by 3. I hope this is clear. Anybody has any doubt? Please check. Shall we find an if a0 is clear? Shall we find an? Is a0 clear?
Yes, ma'am.
Yes, ma'am.
Integration of x power n will be x power n plus 1 by n plus 1. Remember this. Let us find an. It is 2 by L integral 0 to L f of x cos nx. Nx? No, it's n pi x by L into dx, because it's a question on arbitrary period. So it's 2 by L, 0 to L, f of x cos n pi x by L into dx. So it's 2 by L value is 1, integral 0 to 1, f of x is, what is f of x? X minus 1 whole square into cos n pi x divided by L into dx. Let us take x minus 1 whole square as the first term, cos n pi x by L as the second term, and L value is 1. So it will be n pi x by 1. So let us apply this rule, Bernoulli's rule. According to that, first term keep it as it is. So x minus 1 whole square, keep it as it is. Integrate cos n pi x. What is the integration of cos n pi x? It will be sin n pi x divided by the constant term in n pi x, that is n pi, minus differentiate x minus 1 whole square. Differentiation of x minus 1 whole square is 2 into x minus 1 into differentiation of x minus 1, which is 1. Now integrate sin n pi x by n pi. So integration of sin n pi x by n pi will be minus cos n pi x divided by n pi. Already one n pi is there, so it will become n pi whole square. Then addition plus sign. Now differentiate 2 into x minus 1. Differentiation of 2 into x minus 1 will be 2. Differentiation of 2 into x minus 1 will be 2x minus 2. Differentiation of 2 minus 2 will be 0. Differentiation of 2x will be 2. Now integrate this one. It will be minus sin n pi x by n pi, and n pi square is there, so it will become n pi whole cube. Limits vary from 0 to 1. I hope this is clear to everyone. Now let us put the limits. When you put the lower and upper limit, when you put the upper limit, this term will be 0, as well as when you put the lower limit, sin 0 will be 0. So this first term will be 0. Even you can check over here. When you put sin x as 1, sin n pi, which is 0, sin 0 is also 0. So for both x equal to 1 and 0, first and the third term will be 0. Now we need to apply the limits only for the middle term. And here you can check minus 2 into 1 minus 1, it will become plus 2. So we will have 2 into x minus 1 and n pi square. So it will be 2 divided by n pi, n square pi square. What is remaining? X minus 1 into cos n pi x. X minus 1 into cos n pi x. Work out along with me, because these are the questions which we have been learning since almost 8 classes. So it's 2 2s are 4, 4 by n square pi square. What happens when you put the upper limit? When you put the upper limit, x as equal to 1. 1 minus 1 will be 0. Minus lower limit, x will be 0. So 0 minus 1, it will be minus 1. Cos 0 will be 1. So minus of minus, it will become plus. So our final answer will be 4 divided by n square pi square. This is the value of an. Anybody has any doubt in this step? Just look into the step. Just check. Anybody has any doubt? In finding an, anybody has any doubt? So any step, if you have not understood, please ask. Done? So let us write the final answer. F of x is equal to a naught by 2, that is 1 by 3, plus summation n equal to 1 to infinity an. An is 4 by n square pi square cos n pi x, because L value will be 1. So this is the Fourier series expansion of the function f of x is equal to x minus 1 whole square. We have found what called cosine half range series. We have found cosine half range Fourier series. Okay. So one homework I would like to give. Take f of x is equal to x sin x in the interval 0, pi. This is asked in June 17 question paper. June 2017 question paper. F of x is equal to x sin x in the interval 0, pi. Okay. Work out this question. after this class or whenever you are free before my next class, work out this question. F of x is equal to x sin x. Is it okay, everyone? Please respond.
Yes, ma'am.
Okay. Or anybody has any other doubt in any of the questions? Anybody has any doubt? No? Okay, fine. So we'll discuss one more question, then we will wind up. You need to find cosine half range. I hope you'll have taken down this question. F of x is equal to x sin x. Practice this. I have solved this during the class. You might find the answer of this in notebook as well. You try solving on your own. X sin x. Next we'll find cosine half range Fourier series. Cosine half range Fourier series. Cosine half range Fourier series of f of x is equal to 2x minus 1 in the interval 0, 2. So first, what is cosine half range Fourier series? F of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by L, because this is an arbitrary period question. So what is a naught formula? We need to find a naught and an. Now what is a naught formula? It's 2 by L integral 0 to L f of x dx. Now tell me what is the value of L? Can anybody tell me what is the value of L? 2. See, this is half range question, correct? Interval is what? 0, 2. What is the period of this interval? It is 2. Upper limit minus lower limit. 2 minus 0, which is equal to 2. This is half range. Compare this with 0, L. That's why L value will be equal to 2. So we will have 2 by 2 integral 0 to 2 f of x is what? 2x minus 1 into dx. This 2 get cancels. Integration of 2x. Integration of x is x square by 2 minus integration of 1 is x. And the limit vary from 0 to 2. So here 2 get cancels. We will have the upper limit, that is 2 square. Lower limit is 0. Then minus limit is 2, lower limit is 0. Upper limit is 2, lower limit is 0. So here 2 square will be 4, and here what we have? It's 2 minus 0, which is 2, and minus 2. So 4 minus 2 is 2. So we have a naught value is 2, therefore a naught by 2 value will be 1. Is it okay? Is it okay, everyone?
Yes, ma'am.
Yes, ma'am.
Okay, next let us find the value of an. What is an? Formula 2 by L integral 0 to L f of x cos n pi x divided by L into dx. L value is 2, so 2 by 2 integral 0 to 2 f of x is what? It is 2x minus 1 into cos n pi x by L. L value is 2 into dx. Let us apply Bernoulli's rule in order to find the integral of product of two functions. Here 2 get cancels. So we will apply the Bernoulli's rule. First term, that is 2x minus 1, keep it as it is. Integrate the second term. Integration of cos is what? Sine. Sine n pi x by 2, and the constant term is n pi by 2. Minus, differentiate 2x minus 1. What is the differentiation of 2x? It's 2. And differentiation of minus 1 is 0. Integrate this term again. Integration of sine is minus cos n pi x by 2 whole divided by n pi by 2, and previously 1 n pi by 2 is there, so it will become n pi by 2 whole square. limit 0 to 2. We do not write the third step because the differentiation of 2 will be 0. So there is there where you stop it. Suppose if the differentiation of the next term, if it is 0, there you stop it. Now just check the upper limit and lower limit. In place of x, replace x by upper limit and lower limit and check what answer you all get it. If you put that in the first term, x value as 2, so 2 get cancelled, sin n pi is 0. Similarly, when you put x as 0, sin 0 will be 0. So the first term will be 0. Come back to the second term. Here minus of minus, it is plus. So what is there? 2 into n pi by 2 whole square. N pi by 2 whole square. 1 by n pi by 2 whole square. So it will be 4 divided by n square pi square. And what is it you have over here? Cos n pi x by 2. For this you have to put the limit. So when you put x as 2, 2 get cancels, cos n pi remains. Cos n pi. Similarly, when you put x equal to 0, it will be cos 0. So 4 2s are 8. 8 by n square pi square. Cos n pi is minus 1 power n minus cos 0 value is 1. So this is the value of an. Let us write the Fourier series expansion. It is a0 by 2. What is a0 by 2? It is 1. So 1 plus summation n equal to 1 to infinity an. An is 8 by n square pi square into minus 1 power n minus 1 into cos n pi x by L. L is 2. So this is the Fourier series expansion, half range Fourier cosine series expansion of 2x minus 1 in the interval 0, 2. I hope these things are clear to everybody now. Yes or no? Is it okay, everyone? I hope you are able to understand the difference between them. Yes or no? Out of these 4 questions, are you all able to understand the difference? How many of you are able to understand? Please raise the hands. Okay. If anybody who is still not able to understand the difference, please contact me. Do not keep the doubts pending. Okay, learn this Fourier series properly. I have almost taken more than classes. That much I have not even taken to explain this topic. I have taken for the revision more because this is a little difficult topic. Do not refer the textbook. Refer my notes, and if you get any doubts, please contact me. In the textbook, there is a longer method where the concept of even and odd functions are not applied in the beginning. They have introduced in the middle. So if you go with the concept of odd and even nature of functions, lot of your work will be reduced. That's why I say listen to me carefully, and you can also refer my notes, and in case of any difficulty you can contact me. Nikita, are you there in class? Sushmita, Apeksha. Okay. So for any of your doubts, please contact me. Let's meet in tomorrow's class. That's Wednesday at 11 o'clock. Okay. Thank you, everybody. See you all in next class.
Thank you, ma'am.